Okay, friends, I don't want you getting all worked up about all these formulas that we learned in the past couple videos, all these new symbols, it's little sigma, x bar, mu. Statistics should not be about formulas and variables. That's where you start losing touch of what statistics should be. And what is statistics? What should it be? Well, in my humble opinion, it should be a way of taking a snapshot of a population through a sample. That's why the course is called statistics and not parameters. It's called statistics because we take a sample, measure that sample. Standard deviation, what we just got done talking about in the past few videos, is just one more way to look at a sample. All things being equal, if you take two samples, all things being equal, the sample that has a larger value of S, the sample standard deviation, is going to be more varied than the sample that has a smaller value of S. But that's an idealized case when you can actually put two samples next to each other and compare them. I want to leave in this last video, well, I'm actually going to do another video after this if you want to watch where the n-1 comes from. But in this video right here, I want to leave with a couple warnings, I guess, about a standard deviation, because we shouldn't always use it. A standard deviation should not be used by itself. I've actually seen old statistics textbooks that try to do inferential analyses on just a standard deviation, and it really is, it's dumb. A standard deviation only makes sense when it's paired with an average, because remember, we calculated it by taking the difference of the data points from the average. So you really need to refer to the average and the standard deviation together. That's the first thing, and we're going to revisit that moving forward as quickly as the quiz is for this topic. That's the first thing. The second thing is actually tied to that. Since the standard deviation is a function of the average, you have to trust the average in order to trust the standard deviation. And in the last topic, measures of sector, we looked at some situations where you shouldn't necessarily even look at an average. For example, highly skewed data sets. When you have data sets with lots of skew, with long tails on one side and a hump on the other side, the average tends to chase those outlier values. That means the average is going to be larger than it should, and you probably should use the median in that case. Well, if you're using the median, then you shouldn't use a standard deviation, because a standard deviation is based on the average. So I'm just throwing that out there. That goes beyond the scope of what Math 243 is supposed to teach you. I am tasked in Math 243 to teach you what the standard deviation is, how to calculate it, and how to generally interpret it. And later on, we're going to see how it applies to things like the normal distribution. But when you get to practice statistics in whatever your fields are, you have to make decisions. Should I even use the standard deviation? Now, fortunately, I'm not going to retire anytime soon. I'm always here to talk to you about that. But just think about it. Always come back to first principles. What are we trying to do in a statistics class? We're trying to get a valid picture of the population through a sample. We want to do that as accurately and as precisely as we possibly can. So if the data itself lends itself to looking skewed, shouldn't trust the average, therefore shouldn't trust the standard deviation. Now, that's all I'm going to say about standard deviation at this point in this video. In the next video, should you choose to watch it, I want to come back to that point of accurately representing the population with an explanation of why that n-1 needs to be there. It's not going to be a mathematical proof. I tried that years ago and it just backfired. Students didn't like it at all. I think we can look at it through an example that can be generalized. So, if you've had enough, you can just stop this now and try the homework. If you want a little bit more to see where that n-1 comes from, let's take a look.